Okay, so these are notes for Tuesday, tomorrow. And hey, guys, this is probably the first notes that that I've done for your class that isn't pre-recorded. Yay, spring 2021, in case I use these in the future. Anyway, I think I lost the notes that were about graphing these particular functions because heck, I can't find them. So what I have is there is a set of notes that I do have that is basically the second part of these notes that they're kind of extensive, you guys, and I apologize for that, but it is what it is. Sometimes in Algebra 2, the notes go long. I've had days when I was teaching in a traditional high school, I had days where I taught like notes for almost the entire period, like 45 minutes, and then they had to just go home and do the homework on their own. Sometimes notes take long, and that's kind of how these are. But tomorrow we're going to be doing an activity, and then the graphing assignment isn't actually due. The graphing topics aren't actually due till Wednesday. So it kind of gives you a moment to breathe. And tomorrow we'll be doing an activity that hopefully will help you understand these more. Today, I want to get across something that, first of all, math is a lot easier if you understand it and you kind of get like what's happening. Meaning sometimes you can know like overarching ideas and that will help. But sometimes you don't. And so you just need to know like what do I need to do? Okay. And I want you to know that anytime anybody says graph at the most basic level, okay, you don't have to know what this thing looks like. Hopefully you do, but you don't have to. Okay. But oh my goodness. You like that? That's crazy. Let's try drawing that. Go straight. But you do always have input output table for yourself. Okay. So sometimes kids get confused with the X. You can pick anything you want. Okay. I'm going to tell you right now that an absolute value function looks like a V. Okay. You kind of do need to know this for graphing absolute values because you need to find the V, like you need to find the vertex and you need to find where it switches. Often the way I think of the absolute value is like, remember, it's always positive. So it's like this line, this positive slope line here was like do, 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 and then it was like at some point it wants to go into the negative, but the absolute value function is like, and it forces it to go back up again into the, like it forces the function, when I say function, you say y, it forces the function to go back up again. And again, if you don't understand that, that's fine. It doesn't matter. Pick points, any points. Okay. The thing with this is you can see that it's very simple. If this were a line, y equals 2x, you could see that the b is 0, correct? And there is no like lateral translation, which we'll definitely play with tomorrow. But the idea is that let's go ahead and plug in a 0. Just pick some points here, okay? And then you plug it in and you go, y equals 2 times the absolute value of 0. The absolute value of 0 is 0, so it's 2 times 0. Notice you can't actually multiply these. You must find the absolute value first, equals 0. You need to do that in your head. Say that. You don't have to write everything out, but you absolutely need to say that to yourself. Now, let's say you do 1, 2, 3. Then you're going to go, the absolute value of 1 is 1 times 2 is 2. Absolute value of 2 is 2 times 2 is 4. I'm doing these quickly. So if anytime you're doing the notes and you're thinking, oh my God, I need to do this on my own, pause it and then finish it and then come back and check with me. So 3, absolute value of 3, 3. 2 times 3, 6. Okay, well, this is great, but whoa, if you notice, okay, you didn't actually get into any negative zone. You've got 0, 0, 1, 2, 2, 4, 3, 6, right? But look, you've only got one side of this V. You have to know that an absolute value is a V, so we need to go into the negative zone. Okay, boom. -1, -2, -3. Okay, let's plug in a -1. So you go 2 times negative absolute value of -1. Y is equal to Y is equal to, what's the absolute value of negative 1? 1. 2 times 1, 2. 2. Absolute value of negative 2, 2. 2 times 2, 4. Absolute value of negative 3, 3. 3 times 2, 6. So you can see that it's just a reflection. In this case, the axis of symmetry is the y-axis. Okay, the vertex is 0, 0. Okay, and that's how you graph it. You can graph anything with the table, like literally anything. Sometimes you have to plug in like 20 numbers if it was a crazy function, but you can graph anything, and that's beautiful. That's a beautiful thing about graphing. Okay, let me grab this real quick. All right. Wait, let me make sure something. Did I lock everything? I don't know. Let's see. Just sorry. You're gonna have to bear with me for a second. I need to find out if I just screwed up my notes for the future. I did. Okay. Okay. I'm gonna go ahead and lock everything for now. Just, you don't know what that means, but it basically means I can write on it and then erase it. Like all of the rest is locked. Okay. So it says graphing another absolute value. Now this one, I wanted to bring this up because it has a negative. So negative means that the function wanted to go here, but then all of a sudden it said, nope, go negative. Okay, instead. So it flips it. So instead of being a positive v, it is a negative v. Okay, so again, table saves your life. If you don't know the parent formulas, it's perfectly fine. Let's plug in -2, -1, 0, 1, and 2. These are my standard 5 numbers to plug in anyway. Typically, you always want to do some negatives, you always want to do 0, and you always want to do some positives, okay? And what it helps is if you have some kind of order on this side, you will see the pattern come out here as well. If you just randomly put numbers all over the place, then it doesn't have that order, and it's not as easy to predict. So y is equal to negative absolute value of -2. Absolute value of -2 is 2. So the answer, this is this negative. This negative comes down. Absolute value of 2, so it's -2. Okay, so now y is equal to the negative of the absolute value of -1. The absolute value of -1 is 1. Ooh, the answer is -1. 0. Okay, +1. Y is equal to the negative of the absolute value of +1. The absolute value of +1 is 1. So therefore 1. See how this negative is not part of the absolute value? So therefore this is going to be -2. You can see the pattern. And then you graph it. And I don't think the graphing part's hard. So 0, 0, 1, -1, 1, -2. I mean 2, -2, my bad. 1, -1, -2, -2. Boom. V. Okay. You can always plug in points. Okay. Next. Okay, graphing an absolute value in the plain basic. All right, so now take a look at what they did. They added a number in here. Okay, I'm not going to tell you what it does because we're going to discover what it does. But what you need to know is, again, you need to be able to get that V. So we're going to plug in values. Okay, now what value should I plug in? We could start with -2, -1, 0, 1, 2. Let's try it. Let's just say we go with my standard 5 numbers. Let's start. And then you go, y is equal to 2 times -2 minus 2. I plugged it in, right? Y equals 2 times the absolute value of -4. Adding them together. Y is equal to 2 times, times 4. Y is equal to 8. Okay, so we got 8. Now go back, do it with 1. 2 times the absolute value of -1 minus 2. 2 times negative absolute value of -3. 2 times 3. 6. We might have a pattern. You can see it's kind of like in the form of a line, but it's basically 2 pieces of a line. Like I said, it's like as if the line got broken and got forced to go in the other direction. Okay, let's plug in a 0. 0 minus 2 is -2. Absolute value of -2, 2, 4. Ooh, see the pattern? 8, 6, 4. Next one should be 2. Wait, did I do that right? Yeah, I did. 1 minus 2 is -1. 2, absolute value of -1 is 1. 2 times 1, 2. See? Okay, so this is nice. We did this, right? Okay, we're right here, and we graph this thing, and we're at -2, 8, +8, right? Okay, -1, 6, 0, 4, 1, 2, 2, 0. Well, yay, except for not yay, right? We only got 1/2. We have not hit the vertex yet. Hopefully it does nice and straight. There we go. All right, we haven't hit the vertex. Well, that kind of sucks, right? So we got to add more numbers. So even if you pick a table, you guys, you can see, knowing that you need a V, we need to add a couple more numbers. Let's keep going to the right. Let's try 3 and 4. So 3 minus 2 is 1. Absolute value of 1 is 1 times 2 is 2. So there we go. Boom, we got it. Okay, and then the next one's going to go up to 6. You can see that basically you've got your graph. Okay, my point here is that even if you don't pick the ideal numbers, it still will give you direction. So you're like, oh, wait, I still need that V. Keep going. Okay. All right. But notice what happened in the last one. Let's go back. In the last one, notice there was nothing here. Okay. Basically, there's a 0 there. The vertex, this is the form of an absolute value. You might want to write this down. It's A, maybe it's capital A. Hang on. A times the absolute value of x minus h plus k. You've seen this before. This is h and k are the vertex of a parabola. And if you haven't seen it, you're going to see it in a few seconds, okay? So in this case, if we had to put this particular formula, y is equal to the negative absolute value of x, it would be y is equal to -1, right? Because that's what a would be, times the absolute value x minus 0 plus 0. So the vertex is 0, 0. And of course, look, the vertex was 0, 0 when we graphed it. Right there, it's 0, 0. So look here in this one. Sorry, the next one. Here we go. Take a look. The form is this, ready? Y is equal to A times the absolute value of x minus h plus k. H, k is the vertex. Notice here. That's weird. I won't write. Okay. Minus is part of the formula. Therefore, the vertex is at +2. H is +2 because its minus is in the formula. Notice what that did. It moved it to the right 2. See? So what is my vertex for this one? It would be 2, 0 because there is no k. +0, right? And it always follows the minus sign. Okay? We'll get more into that in just a little bit, so I'm not gonna really go hard into that right now. Okay, right here, y is equal to -5 absolute value of x minus 2. Let's compare that. Y is equal to a absolute value x minus h plus k. So in this case, look, we have a k. Now notice how it's a plus. It's a plus in this thing. So if it's a plus, it means this is like a plus -2. We take the sign that it is. Okay, notice there is no h. So in this case, the vertex is going to be 0, -2. Now let's verify that with this, x and a y table. Okay, we're going to plug in my standard 5. Okay, we go absolute value of -2 is 2 times, might want to do this. So let's plug in -2. -12. Okay, now we're going to plug in -1. Again, if you need to do this and I'm working too fast, just pause the tape, do it on your own, and then come back. Because a lot of you are still struggling with, not a lot of you, but a few of you are still struggling with integer stuff. So if that's your situation, you want to give yourself practice for that. Okay, I'm just going to plug in a 0. That's going to 0 that out. It's going to be -2. Okay, 1 is going to be the same thing as -1 in this case because there's nothing. So it's going to be -7. There's nothing else operating on it, and this is going to be -12. All right, so let's take a look at what happened to our graph. -2, -12. So here's -2. Let's say this is -12. Okay, -1, -7. I'm going to call this -7 right here. 0, -2. So what did it do? It went here where it was normally supposed to be at 0, 0. It moved it down. It translated it down 2. And then 1 is 7, -7, and 2 is -12. So we have an upside down V, which you knew it was upside down. Sorry, it's really hard to graph on this, you guys. You knew it was upside down because of this. You knew it was a V because of the absolute value. The vertex was 0, -2. So it all checks out. Next. Keep doing that. Sorry, guys. Wrong direction. All right. So now is the graphing the basic parabola. Okay. It says plot 5 points. You have to plot the vertex, 2 points to the left and 2 points to the right. Now, tomorrow you're going to learn that this is actually, there are parent formulas for every one of these. Parent formulas for every graph. And it's basically where all coefficients are 1 and there are no lateral or vertical movements. Okay, no horizontal or vertical movements. It's like the most basic that it could be. And y equals x squared is that. I do want to prove to you, you can graph points. Okay, pick my standard 5. Okay, and you could plot these points and you will get -2. Notice when you plug in a -2, you got to put it in parentheses. Okay, because -2 squared is not -2 squared. This equals -4. This is equal to 4 because this says -2 times -2. This says take the negative of 2 times 2. See the difference? So plug it in that way. You're going to get 4. This is going to be 1, 0, 1, and 4. Again, if I work too fast, pause. Okay, so let's plot this. -1, 1, it's x squared. So hopefully by now you know that's going to be a parabola. And if not, you sort of will feel it out right here. Okay, because it's starting to do this weird like, woo, it's not a line. Obviously not a line. There's no constant here. Absolute value is basically a line kind of slope, well, it is a slope. It's just that it's not a consistent slope because it switches halfway through. Anyway, parabola. Okay, and it actually told you it's a parabola. Okay, positive parabolas go cup up, negative go cup down. Next one. And I keep hitting the wrong letters. Okay, now predict this. What's happening here? It's a negative, so we know it's going to go down. What does the 2 do to the x squared? It's basically saying your function, your y, like you put in an x into this function, and it's going to take the normal value and multiply it by 2. So that means it's going to increase or decrease even faster, twice as fast. Okay, plot 5 points. Again, x, y, -2, -1, 0, 1, 2. These are great points for parabolas because they're just easy. So y equals -2 times -2 squared. That's how you plug that in. Y equals -2 times -1 squared. And y is equal to -2 times 0 squared. Like you can plug them all in, right? This one is going to go to -2 times -2. I can cross that off and write a 4. It's going to be -8. -1 squared is 1. -2 times 1 is -2. 0 is 0. -2 times 0, 0. 1 is going to be the same as this, which is -2, -8. Okay? And then you just graph them and move on. Okay? I'm not going to do that for the moment because I have a million problems here today for you. Okay, so what is this going to do to this graph? It's going to move it. Well, let's see what it does. Okay, again, parent, y is equal to ax squared plus bx plus c. This c is that c. Okay, y is equal to a times, this is vertex form, right? In vertex form, notice that we actually c is equal to k because it's a special, well, no, that's not, c is not equal to k. What the crap am I talking about? Baka, you lost it. C is not equal to k, that's why it's a different letter. Okay, but let's find out what c is. Okay, so let's do this. X, y. -2, -1, 0, 1, 2. Okay, let's plug it in. -2 squared is 4, 4 minus 6 is -2. -1 squared is 1, 1 minus 6 is -5. 0 squared is 0, 0 minus 6 is -6. 1 squared is 1, 1 minus 6 is -5. -2. What did it do to our graph? What did that -6 do to our graph? Okay, normally y equals x squared looks like this. It goes through 0, 0, goes like that, right? This is y equals x squared. What did adding that -6 do to it? Okay, 2, -2. 1, 1, -5. 0, -6. Wait, that doesn't. 2 is not -2. Spock, I don't know why I did that. You guys, I hope you found that error. I just like assumed. I don't know why I did that. That's stupid. Yeah, it is. Wait. Yeah, it is. 2 minus 2. Okay, is -2. What did I do wrong? 2, -2. Negative. Oh, it's negative. Wait, it's 1, -5. 0, -6. I didn't do anything wrong. I just thought I was going in the other direction. I'm sorry. You just watched me have like a brain fart, but it's okay. I have them too. All right. So this is the parabola. So what is that -6? Notice. What did it do to the graph? It moved it down 6. Okay, and look, what is that C? It's the y-intercept. Look how cool that is. You can tell what the y-intercept is because at the y-intercept, x is equal to 0. And if you plug in 0 for x, look what happens. You get y is equal to c. Basically, you get your y-intercept. So, get it? It's kind of cool. All right, next. All right, I think this is where my other notes took off. And so I'm going to go ahead and stop here. I think this is where my other notes took off, actually. I'm not going to do that. Well, yeah, I will do this real quick. Again, I'm doing a lot of problems, you guys, because it helps sometimes just see what's happening. -1, -2. Oh my God. -2, -1, 0, 1, 2. Okay, -2. So we're going to plug it in. And then we're going to discover what happens here. Notice now we have a negative in the front. So hopefully you kind of imagine that it's going to flip the parabola upside down. What's that +5 going to do? Okay, so -2 squared plus 5. This becomes a +4. So it's -4 plus 5. That becomes +4, right? And you get 1. Try the next one. Y equals negative of -1 squared plus 5. This becomes +1, and you get 4. Plug in a 0. Y is equal to -0 squared plus 5, which is 5. And then 1 is going to be 4, and 2 is going to be 1. Okay. When you graph this, look what happens. -2, 1, negative 1, 4, 0, 5. And then 1, 4, and then 2, 1. So look what it did. It flipped it like we thought. Oh my God, these are impossible to draw. On this particular app, it's so hard to draw. It's so hard. I am sorry. I'm sorry. It is ugly. Okay, please don't draw yours as ugly as mine. Notice what it did. It moved the graph up 5 and it flipped it. Okay, next one. Okay. Now we've got a negative 5 and a negative 2. What the heck? Let's look at this form. HK is the vertex. Look, minus H. Okay, so in this case, H is actually 2. And Y is equal to negative 5. So your new vertex is at 2, negative 5. Okay, now you can plug it in to check this out, but just want to make sure that you start to notice that these formulas are actually like code. It's really cool. It's like secret code. If you can read the formulas, you know so much about this stuff. Okay, X and Y. So if we're plugging in points, okay, what we know is that if our vertex is at 2, negative 5, okay, we know we need to go to the left and the right of here in order to know, okay, like what speed it's going to do it. By the way, it's cup up because A is positive, so it's going to be cup up. So I'm going to pick 0, 1, 2 because I want my vertex to be the middle, 3, 4. That's my H value of my vertex, the X value. Okay, this is 2, negative 5. And I want to go this way 2 and that way 2. Okay, by the way, I think I say this later. It's just you can always plot 2 points to the left and then reflect them over. Once you have your vertex, you are home free. In this beginning part, we're just plotting points. I just want to prove to you that plotting points always works. If you could do the math, 0 minus 2 is negative 2, squared is 4, minus 5 is negative 1. So 0, negative 1. Okay, what is 1? Let's go with 1 minus 2 squared minus 5 is negative 1 squared, which is 1 minus 5, which is negative 4. 1, negative 4. Okay, now that we know that, we could actually reflect it. We know that 3, when we plug in a 3, it's going to be 3 minus 2, quantity squared, minus 5. That's going to be 1. It's going to be negative 4. Okay. There. And 4 should be negative 1. Let's try it. 4 minus 2 squared minus 5. This is 2. 2 squared is 4. 4 minus 5 is negative 1. Okay. And it works out. Hope you guys got all of that. Now the other notes take off from here. Okay. I'm not making them due until Wednesday as well, just because they really are long notes. Okay.